Okay, so today is our first chapter of physics is the scope of physics. We will study today the dimension topic. The topic is dimension. What is dimension? Nature of physical quantity, or we can say the power of basic quantities, is called dimension. Physics prove that every equation has equal dimension on both sides. We will prove this further. This is now basic, so we can't prove this. Dimensions are written in a square bracket in this way. Okay, as we know, basic quantities are 7 in physics: distance, mass, time, current, temperature, amount of substance, luminous intensity. The dimension of these all are represented by dimension by L, mass by capital M, T by capital T, current by capital A, temperature by capital K, and this mole and CD. Okay, as we know that distance, radius, length, width, height, circumference, distance, displacement, these all are actually a distance covered. We can say that they cover a little bit distance, or they cover uh, radius is also a distance of a circle. These all are means they cover length. So these all are the quantities. In these quantities one thing is common. Which common? Know that distance is covered by these all. These are denoted by L. Whenever we are getting in any equation, we are getting that length or width, whatever, so we will represent these all by capital L. Okay, now we are finding dimensions of basic ones. Volume, we know that volume is equal to a length into width into height. Length will be represented by capital L. Width also a length is covered distance, or it is the distance between 2 points. So width will be capital L, and h will be also capital L, and L into L into L is equal to L cube. Or we can say that these wait a minute, this length, mass, and time, these are mostly used in terms of physics. These all are not any important, but these are the main common are the distance, time, and mass. Okay, so here mass is 0 because no mass, and length is 3, length cube, and t is 0 because no time and no mass is given in volumes. Okay, area is equal to length into width. Okay, length into length is length square. We can also say that m0 l2 t0, because in entry test they ask what is the dimension of area, and they give option of this, so you have to learn this also. Okay, velocity, as we know that s is equal to v is equal to s upon t, distance upon time. Distance is a length, so will depend by L, and t is a capital T, time. So when t moves upward to the L, so power will be minus, so LT minus 1, and will be closed in a bracket, square bracket. Okay, so this is the acceleration. Acceleration is equal to delta V upon T. As we know, delta V means velocity. Velocity is equal to LT minus 1. Here we find. So LT minus 1 and T, this one T is a capital T. Capital T will be remain same as a capital T. So LT minus T, LT minus 1, and this one T will comes up and will be minus 1. Okay, because this is the positive one. When it comes upper in the numerator, in the power will be negative. Okay, so LT minus 2. The acceleration of the dimension of acceleration is LT minus 2. The second is F is equal to ma. Force is equal to ma. Force is equal to m will be represented as capital M, and acceleration, the unit of acceleration is meter per second square. So F is equal to meter, and meter per second. Meter means length. It's a distance. So it will be written as L, and second means time, t square. So m multiplied by L and divided by T. Okay, when T comes in the numerator, it will be minus 2. So the dimension of force is MLT minus 2. Okay, the formula of work is force into displacement. As we know, force is equal to MT minus 2, and into D. D is a distance. Distance will be represented by L, and V is equal to ml square, because L and L plus 1 will be plus 2 and T minus 2. Okay, power is equal to work done upon time, per unit time. So work की dimension क्या आई थी हमारे पास, ml2 T minus 2. We will put here same, and T is equal to capital T. When minus 2 and when this T plus this T contain plus 1 power, so when it will be coming in the numerator, it will be minus 1. So minus 2 minus 1 is equal to minus 3. Okay, momentum P is equal to mv, m is equals to lt minus 1. Velocity, we have already found lt minus 1 is a dimension of velocity, so we will written our mlt minus 1. Okay, now the formula is torque. T, this is a sample of torque, is equal to force into radius. Okay, radius is also length, so force की dimension क्या थी, mlt minus 2 multiplied by L, because radius is also a length, so ml square T minus 2 is a dimension of torque. The second is potential energy. Potential energy is mgh. M multiplied by g here represent the acceleration, and the acceleration is lt minus 2. Okay, lt minus 2 multiplied by height is also a length into length, m into L square, because L into L is L square, and T minus 2. Okay, angular frequency, and we know that in dimension we don't concern with the numericals and that pi's and radical, we only neglect them and move on. So angular frequency is equal to 2 pi frequency. So 2 pi will be neglected because 2 is a numerical and pi has no dimension, so neglected. Frequency is equal to T minus 1. How? Because frequency is equal to 1 upon T. Okay, so when this T plus 1 and AB, so this T will come, when positive T will come into numerator, it will be minus T, so f is equals to T minus 1. Okay, so this is a dimension of angular frequency. The second is E is equal to mc square. Here C represent velocity. Okay, this is the formula of energy. E is equal to m into m, same as a capital M, and velocity is equal to lt minus 1 upon square. तो ये स्क्वायर एल पे भी आएगा एंड टी पे भी आएगा, एम एल स्क्वायर टी माइनस 2. ओके, this will be the dimension of energy. Put with the pressure, the formula of pressure is force per area. Area is equal to L2 because length into width, and force is equal to mlt minus 2. Mlt minus means this is the positive 2, when it comes in the numerator it will be minus 2. So plus 1 minus 2 into T minus 2. So plus 1 minus 2 will be minus 1 upon T2. The dimension of pressure is ml minus 1 T2. T